Hello friends, welcome to this channel Dr.ARM's Chemistry. We were studying the synthetic methods, and today we are going to see the next method for the synthesis of Schwartz reagent. The method synthesis of Schwartz reagent. So this is important reagent in the synthetic organic chemistry, and it is prepared from zirconium compound. It is prepared from zirconium, Grignard, Cp2, Cl2 by reduction using lithium aluminium hydride. So here we take this Zr is Cp2 Zr Cl2. So when it is reduced by lithium aluminium hydride, it gives the product that is Cp Zr Cp cyclooctatetraene Cl H. So this is our Schwartz reagent. Synthesis of arene sandwiched compounds. Sixth method, synthesis of arene sandwich compounds. Synthesis of arene sandwich compounds. So the aromatic ligands such as benzene or any other compound like that may bound to the metal using their variety of carbons. If we take benzene, it can have the points of attachments, that is 1 to eta 1 to eta 6. So depending upon the availability of pi electrons, the metal sandwich compounds can bound to the show the bonding between metal and aromatic rings as eta 1, eta 2, eta 3, etc. So we will see some examples in which such type of this is the metal benzene ring. So it has 6 points of attachments. So it is called eta 6 complex. Similarly, we can have so here also we can take these 2 bonds. So it can have the bonding for these 4 carbon atoms, and therefore it is eta 4 metal complex. Now we will take the another example where we can have the structure like this, and the bonding is like this. Here the metal is bound in this way, like this. So this is eta 3 bonding, and when we have the benzene like structure like this, it can have this M, that is only two carbons are coordinated here, therefore it is eta 2 complex. So these are some examples in which the amines and which compounds are shown. Now we will see the example in the synthesis, that is CrCl3 plus twice Al plus AlCl3 plus benzene 6C6H6. So it gives sandwich compounds in which there are like this. So this will have attachment with this chromium, so we can show this pi electron cloud as like this. So this is having one positive charge and this is neutralized by AlCl4 minus. Now this is further treated with QH and Na2H2O4, so that it gives the compound like this. Like this. So this is our product where two benzene rings are here attached. Now we will have another example. So if we take the substituted benzenes like this, so here these are amine. Then this will have the complex like this. Complex with two methyl substituted phenyl rings. This is having 2 plus charge when it is reduced by using liquid sodium and liquid ammonia. So it is giving us So in this way we can get similar type of product here because of the reduction. And one more reaction can be shown in this way. Plus Cr CO6. So it gives so in this way we can have the product where allyl compounds are obtained. So these are some examples of synthesis of brain sandwich compounds. Now we will see the next method. Seventh method is synthesis of allyl complexes. Synthesis of allyl complexes. So allyl groups can bind to a metal in two ways. Allyl groups can bind to the metal by two ways. One is using only one point of attachment, that is eta 1 allyl. For this purpose there is sigma bond formation. So these alleles means this is bound to the metal by sigma bond with free carbon-carbon double bond. And second way is eta 3 alleles. Means in this case only one carbon atom of allyl group is bonded to the metal. Here three carbon atoms of the allyl group are bound to the metal. So here also three carbon are bonded to the metal. Here the three carbons have same bond distance with three carbons at same distance from metal. Means actually in this case the metal is fluctuating between carbon atom number 1, 2, 3 like this. So it is also available simultaneously at 1, 2, 3. Means it is not fixed at a fixed carbon atom. So metal bonding is like the switching bond, metal allyl bond is like a switching, means it is not fixed at any particular carbon, but it is available to all the 3 carbon atoms, because it is switching over from one atom to another to third, or like that. So it has 3 modes, eta 1 to eta 3. 3 modes. There are 3 modes of bonding carbon, that is metal carbon bond. Coordinated allyl groups, as I have said, that is, it has not fixed. Now we will see some. So if you take the chloride Cl CH2, like this. So this allyl plus complex sodium MnCO5, so it gives minus NaCl, and this carbon is bonded to this Mn, so we get that CO5 Mn, and this bonding is taking place to this, that is this CH2, CH2, CH2. So here this double bond, carbon-carbon double bond is not affected, it remains free. So after hitting, the carbon monoxide is lost, one carbon monoxide is lost. As a result of this, we can have these 3 carbons like this, and the pi electron cloud is like this. So it is shared, this bonding is shared with the 3 carbons, so that is eta 3, and it is shown like this, MnCO4. So this is eta 3, but it is switching from eta 1 to eta 3. Then another method is, so this is from allyl halides. So this synthesis is from allyl halides. Now you see another example from alkenes. So you can have this alkene like this, R, CH2, like this. This is the pi bonding metal is taking place with palladium. So this complex is, when treated with a base, it gives similar product, that is this way we get this alkenes. Now the next method is using Grignard reagent from Grignard. For example, if we take NiBr and when it is reacted with alkyl, that is twice C3H5MgBr. This is Grignard reagent. So it gives the complex Ni eta 3 C3H5 twice plus this twice MgBr. Then another example is using zirconyl chloride, ZrCl. It is also reacted in the same way, 4 C3H5 MgBr. It also gives, that is zirconyl C3H5 4 plus 4 MgBrCl. So these are two examples shown for the synthesis using Grignard's reagent. Method is by vapor phase condensation. By vapor phase condensation. Here we will see this example of pH CH2 Cl in gaseous state. pH CH2Cl in gaseous state. Here we are taking this palladium in zero oxidation state, also in gas phase. So it gives the product. Like this. And this CH2 means here this carbon and this carbon. So the three carbons are coordinated here through pi bond, and this is coordinated to palladium. So this palladium is further bridged with Cl. Like this. So these are eta 1, eta 2, eta 3, eta 1, eta 2, eta 3. Means the bond is not localized. It is switching over from eta 1, eta 2 to eta 3. Now the next method, allyls from cyclobutadiene complexes. Cyclobutadiene complexes. Here, when the system is cyclic conjugated, the cyclic conjugated system is there with pi bonds. Then it is aromatic. It is aromatic if the number of pi electrons is equal to 4n plus 2. Here n is integer. But here cyclobutadiene is anti-aromatic. Anti-aromatic since it has 4 pi electrons. So it has 4 pi electrons. In this case, in the case of cyclobutadiene, there are two important features of this cyclobutadiene, that it is anti-aromatic. So this is one thing, and it has ring strain. This is anti-aromatic. In addition to this, it has ring strain. Therefore, it becomes highly unstable. Therefore, it is highly unstable. Then, if we want to prepare the stable cyclobutadiene coordinated complexes, then we can also have some methods like this, or that is like, so a stable metal coordinated cyclobutadiene, a stable metal coordinated cyclobutadiene molecule is like this. Here it is eta 4, means all the 4 carbons are coordinated with the metal. So eta 4 C4H4 nickel, and in addition to this, it has bridging chlorides 2 and non-bridged 2 chlorines. So this was prepared by Grignard. In 1959. So we will see the example. So the methyl groups are coordinated in this way. So this cyclobutadiene tetramethylated dichloro cyclobutadiene, here it is treated with nickel CO4. So it gives the complex like methyl. So in this way we get this cyclobutadiene complex with nickel, where the cyclobutadiene moiety is tetramethylated in both cases. The nickel is bridged, the two nickels are bridged with two chlorines, and this nickel is having terminal Cls. Another example where we can find the mixed sandwich compounds. Mixed sandwich compounds. For example, can have CpCO, Cb. This is Cp means cyclopentadiene, CO is metal, and this cyclobutadiene. So we can prepare this in this way. This on irradiation with H nu and Et2 ethyl diethyl ether, we can get this intermediate. Like this. So this one, when reacted with a this is eta 5 part. this is eta 4 mode and this is eta 5 mode. So the yield of this product is just 17% and therefore it is not much useful. The name is like this, eta 5 cyclopentadienyl pentadienyl cyclopentadienyl eta 4 cyclobutadiene butadiene cobalt So being the very low yield, this compound and its analogues have turned out to be not much having the potential for this competition with ferrocene. There is similarity of ferrocene with this complex, but the yield is much less than that of ferrocene, and therefore it cannot stand as the competitor to the ferrocene, and therefore there is no more development in the history of these complexes. The next type we will see here, cycloheptatriene and cyclooctatetraene. Cycloheptatriene and cyclooctatetraene ligands, and we can prepare variety of these compounds. For example, if you take the vanadium carbon monoxide, means hexacarbonyl vanadium complex, when it is reacted with heptatriene CCA1H8, after heating at 65 degrees centigrade, it gives the complex like this. There is 1/2 H2 plus CO3 thrice CO carbon monoxides. So these are some synthetic methods for these organometallic compounds. Still there are more methods which we will see in the next lecture. So till then, goodbye, see you next time. If not yet subscribed, please do subscribe, and also do not forget to press the like button.